All right, you guys. So we're going to be starting our first chapter. Well, this is chapter one or chapter two. I think it's chapter 1.2. I don't know. Anyway, we're going to be looking at atoms and talking a little bit about chemistry in the first part of this class. Okay, so to begin, let's talk about matter. Matter is, by definition, anything that takes up space and has a mass so that you can weigh it. Okay, so that is the definition of matter. Now, everything on Earth is made of matter. All the living things, all the non living things, even the stuff in the air is matter, or the stuff that makes up air is matter. Like how we talked about with the cell being the basic unit of life, the basic unit of matter is going to be the atom, which is why today's notes are going to be about the atom. Okay. Now, it's important to understand what atoms are because they are the ones that make up matter, and matter make up all living things. So we're going to learn more about atoms. So, what are atoms? Atoms are the smallest unit of matter, as I mentioned a little earlier. Each atom has its own unique number of subatomic particles. Subatomic particles are smaller parts of an atom, and each subatomic particle has some kind of charge, like an electrical charge. And we'll talk about that in a little bit, right? There are three kinds of subatomic particles. You have your protons that have a positive charge, you have electrons that have a negative charge, and then you have neutrons which have zero charge. Okay, so these are the three parts of an atom. Now, as a rule, the number of protons and the number of electrons should be equal. They should be the same. So if I have 5 protons, I should have 5 electrons. If I have 3 protons, I should have 3 electrons. Okay? But the number of neutrons that you have can be different. So I can have an atom that has 5 protons and 5 electrons, but it can have 6 neutrons or 8 neutrons. It will be different. Here is what an atom looks like if I were to draw like a picture to represent an atom. The middle of the atom is called the nucleus. Okay, this part here that you see. And in the nucleus, you're going to have your neutrons and your protons kind of stuck in the center, clustered together, like a little ball in the middle of the atom. Electrons are going to be found outside the nucleus. They kind of spin around the outside, like the Earth and other planets go around the sun. Your electrons are going to be outside of the nucleus, and they are going to be found in spaces that we call electron orbitals. Okay, so if I take the picture and I flatten it out just to show you the electrons and the orbitals, here's the nucleus in the middle. The electrons kind of move around the outside in these spaces. The electrons that are closer to the middle have low energy. The electrons far from the middle have high energy. And this is going to be important for us when we talk about how atoms stick together to form bigger things. Okay? The electrons that are super high energy, they're going to be like little kids with high energy. They just want to bounce around and find things to play with, right? So, same thing here, or very similar at least. Now, those that are the furthest away from the nucleus are in an orbital called the valence shell, and we call these electrons valence electrons. Valence electrons, are going to be the ones that are going to form something called a bond with other atoms. they're going to allow one atom to stick to another atom and make a little bond. When you have atoms bonding together, right, you make something called a molecule. For example, water is a molecule. We took two atoms that are called hydrogen and one atom of oxygen, and all three are bonded together. You make a molecule called water. When we write the atoms out in the molecule, right, we write it as a molecular formula or chemical formula. And the one for water is H2O. The H stands for hydrogen. The 2 down here, it's kind of like in between and smaller, means that there's two hydrogens. That 2 says there's two hydrogens. And then O stands for oxygen. We don't have a number next to O because there's only one. So we don't need the number 1 next to it. Now, the number of bonds that an atom can have depends on how many free valence electrons there are. Okay, because each electron can make a bond with something else, with another atom, basically. But they have to be free. And what does that mean? Well, electrons like to travel 2 by 2. They like to be paired up. Okay, so a free valence electron is an electron all the way outside of the atom that doesn't have another electron to pair up with. They don't have a friend, and they're looking for a new friend. This can be anywhere from 0 electrons, I know that sounds silly, to 4 electrons. Again, depending on how many still need to pair up with another one. Some atoms, when they have a free electron, like this is one atom with one free electron and this is one atom with another free electron, they share their electrons to make the bond so that now this one has a friend. They pair up like this and they share it. They form a bond called a covalent bond. Okay, equal sharing. Some atoms, though, they don't want their electrons. And some atoms really, really, really want to steal electrons from other atoms. So if I have this atom with an electron and it wants to give away its electron to somebody, and then I have this atom that wants to steal an electron so that this electron can have a friend, okay? When they form a bond, this one steals the electron, so now it has 2, this one has 0, and that's how that bond gets formed. We call this kind of bond an ionic bond, okay? So if the atom has a free electron and another atom has a free electron and they share it so that they now each have 2 because they're sharing, covalent bond. If you have an atom with an electron and an atom with an electron where this one wants to give the electron away and this one wants to steal, then it's going to take the electron away. This one will now have 2, this has 0, and that's another kind of bond, ionic bond. Okay. Now, giving away electrons and stealing electrons doesn't always happen only in bonds. Sometimes atoms do this naturally. Sometimes when the atoms do this, they make what is called an ion. Atoms that lose electron are an ion that has a positive charge, right? An ion is an atom that has a positive or negative charge. So if an atom loses electrons, it becomes positively charged. We call them cations. If an atom gains electrons, it becomes negative charge. We call it anion. Okay? So again, normally an atom is going to have the same number of positive protons, negative electrons. So if I have 5 positives and 5 negative, they cancel each other out. You get 0 charge, right? Plus, negative, They cancel. If an atom loses an electron, but it still has 5 protons, then I don't have that canceling. I still have a positive charge. So, because of the proton. So, if an atom loses electrons, that positive electron becomes the new charge on the atom. If an atom gains an electron, but it has one less proton, let's say that it was 4 and 4, so that they're equal. But if this atom gains electron, then again, they don't cancel out and you have a negative charge because electron is negatively charged. Okay. Molecules can also make ions. Water sometimes will break down into a hydrogen ion or a hydrogen atom and something called a hydroxyl, which is one oxygen and one hydrogen atom. Okay. The hydrogen is a cation, and you write it as H plus because it has lost the electron. And the other one, the oxygen hydrogen ion, is an anion, and it's written as OH minus because it took the electron from hydrogen. So they broke down into 2 pieces. We'll talk more about that when we talk about water. Okay. So all of the atoms that have the same number of protons, same number of electrons, we call them elements. So all the atoms that have 8 protons and 8 electrons is the element oxygen. All atoms that have 6 protons and 6 electrons is the element carbon. Okay, because they share the same characteristics. They do similar things to each other. All of the elements that we know is going to be found in the periodic table, and you will get a copy of the periodic table to use, and you can use that periodic table on every test or quiz that we have that you will that is going to ask you about it. On the periodic table, you're going to find boxes like this. Okay, the letter here, kind of in the middle, is the symbol that we use for the element. Okay. And underneath that letter is going to be the name. So oxygen, we use the letter O to represent oxygen. Here is the periodic table. You can see oxygen is over here. Okay. Carbon is right here. Nitrogen is right here. So all of these are different elements, and they all have the same structure, the same shape of their atoms. At the top of the little box is something called the atomic number. The atomic number says this is how many protons oxygen has. Oxygen has 8. Since the number of protons and electrons are going to be the same in a normal oxygen atom that is not an ion, this oxygen would also have 8 electrons, right? So atomic number tells me that there's 8 protons. I know that protons and electrons should have the same number, so I know there's 8 electrons. Down here is something called the atomic weight. Remember, all matter has mass or weight. You can weigh it. So the atomic weight of an atom is written at the very bottom, and it tells us how many protons and neutrons in total there is in the nucleus. So taking a look at oxygen, the atomic weight is 15.99999999999, right? We can round that up to 16 because we don't want 0.9 of something. So the atomic weight is 16. I know that there are 8 protons in the nucleus. So if I take 16 minus 8, I will be able to tell that there are 8 neutrons. Okay? So as I've mentioned, we can figure this out, right? Protons is 8 by the atomic number. Neutrons is 8 because I take the atomic weight, subtract the atomic number. And, oh, sorry, forgot to click that part. And electrons is 8 because we know that the number of electrons and the number of protons is the same. Okay? So hopefully that wasn't too confusing. You will be working on a worksheet tomorrow where I will help to kind of walk you through how to do it. If you check the assignment on Canvas tomorrow and you're not sure how to do it, there's a video um, that I will post to show you step by step how to read the periodic table to work on the atoms worksheet. Okay, have a good day.